Okay, so today we're going to talk about geometric sequences. A geometric sequence is a sequence where the ratio between consecutive terms is constant. We're going to call that ratio R, but a ratio is basically a multiple. So you could have a sequence like 2, 4, 8, 16, where you're constantly multiplying by 2. That's a geometric sequence there. All right? And so we have a formula to find that ratio, very similar to our arithmetic sequence, but instead of subtracting the terms, we're going to divide the terms. So again, when we see a sub n, it means you pick any term in the sequence and you divide it by the term that's directly in front of it. Okay? Divide any term by the previous term. Recursive formula, very similar to the arithmetic one. To find any term in the sequence, you're going to take the term before it, but instead of adding d, you're going to multiply by that ratio. Okay? Again, the recursive formula finds terms in order. So if I wanted to find the fifth term, a sub 5, I would need to know what a sub 4 was, and then I would multiply that by my r value, and I would get a sub 5. Explicit formula, a little different here as well. A sub n, to find any term in the sequence, we're going to take the first term and we're going to multiply it by r n minus 1 more times. So again, think about this. If I wanted to find the 10th term, okay, and I knew the first term, I would take that first term and I would multiply it by r 9 more times to get to number 10. This formula finds any term in the sequence as long as I know a sub 1 and r. Okay? So we've got a couple of sequences here. The first one is 15, 3, then it goes to 3/5. So we're getting into some fractions here. And it says find the common ratio of the geometric sequence. So when we say common ratio, we're always going to say, what are we multiplying by to get from one term to the next? So a lot of you guys are going to look at this and say, oh, you're going to divide by 5. Nope, we're not going to divide by 5. We're going to take any term in the sequence, like 3. We're going to divide it by the term before it. Our ratio is 1/5. So if I multiply by 1/5, I get the next term in the sequence. It says then find the next two terms. Well, for me to find, this is a sub 1, a sub 2, and a sub 3. For me to find a sub 4, I'm going to need to take a sub 3, and I need to multiply it by 1/5. So there's a sub 4, 3/5 times 1/5. So 3 times 1 is 3, 5 times 5 is 25. A sub 5, I'm going to take a sub 4, 3/25, multiplied by 1/5. 3 times 1 is 3, 25 times 5 is 125. All right? You should be able to do the next one on your own. All right, so my common ratio here is -1/2. I took the second term, -4, divided by 8. I got -1/2. To find the fifth term, I'm going to take the fourth term, -1 times -1/2 is +1/2. And +1/2 times -1/2. -1 times 1 is -1. 2 times 2 is 4. All right, find the indicated term of the geometric sequence. Here we go. So this is a sub 1 in the front here. This is a sub 2, a sub 3, and then I'm missing some terms. And then all of a sudden I need a sub 8. So I cannot use a recursive formula, but what I can do is find my r value very easily. All I do is I pick one term in the sequence and I divide it by the term in front. So I did 18 divided by 36 and I got 1/2. Once I know my r value, all I need is my explicit formula again. A sub n equals a sub 1 times the value of r to the power of n minus 1. What do I know here? I know a sub 1 is 36, and I know that r is 1/2. So I'm going to plug those two in. Let's see what we got. So it looks like I skipped a little bit here. So a sub 8, okay, there's my a sub 1, 36. There's my r value of 1/2. Since I'm looking for a sub 8, I'm going to put 8 in for n. And if I put 8 in for n here, I would subtract 1 and I would get 7. Now a lot of these you're going to want to just pop out a calculator for these. If you do that, if you actually do it without a calculator, you get 1/2 to the 7th power is 1 over 128. And 36 times 1 over 128 simplifies to 9/32. All right? I don't know what the decimal value is for that. Look at part B. I'm going to do the exact same thing. I'm going to look for the R value. Now the R value is a little bit trickier here. I need to take the second term divided by the first term. I could take the third one divided by the second one. Doesn't matter. I did the first term divided by, or excuse me, the second term divided by the first term. But this is division of fractions, which means this second one needs to flip over. So, not sure why we have a G in here. That should be a times sign right there. 1/5 times 25 over 1. Do a little bit of canceling here and you have an R value of 5. I go back to my recursive formula, same one we used over here on the left side, and I'm going to plug in. We're looking for A sub 7. So here we go. A sub 7 equals the first term, 1 over 25, times the ratio of 5, raised to the power of 6. And you get, now look at what I did here. I had 5 to the 6th up on top here, and I have 5 squared down here. That means I have 6 5s up here and 2 5s down here, so I canceled off 2 of them. That left me 4 5s, which is 625. Okay? All right, number 3, write a recursive and explicit formula for the sequences in example 2. All right, so here we go. Recursive and explicit. Again, I need to know the R values. We did that. Second term divided by the first term was 1/2. A recursive formula uses this guy. A sub n equals A sub n minus 1. You'll notice I didn't plug anything in for these guys here because it just wants the formula times 1/2, and that's it for the recursive. This one's done. There's no exponent on the recursive formula. Because again, think of it like this. If I wanted to find the 10th term, I would take the 9th term and I would multiply it by 1/2, and that would give me the 10th. Here's my explicit. A sub n. To find any term in the sequence, I'm going to take the first term, I'm going to multiply it by 1/2, I'm going to raise it to the n minus 1 power. Now if I said find me the 20th term, you could plug in 20 down here and 20 up here. Why don't you guys try part B? All right, so we had the R value of 5. Again, this should be times in here. Our recursive value. Look at this. This time I use the f of n notation. And because I used f of n on the left, now really what I did over here is fine, even though if I'm going to do f of n over here, I really should do f of n minus 1 over here. Okay, so either way I could do that. But in fact, maybe I can write this one out for you. So let's see what we've got here. So I'm going to try. There we go. So this really should look like this. F of n minus, or n equals f of n minus 1. That's the value of the term before, times 5. Okay, so that's really what that should look like. My explicit formula is f of n equals 1 over 25, that's my first term again, times 5, to the power of n minus 1. And this one is correct, because whatever n this is, so if I said find me the 5th term, you'd plug in 5 here, and you'd end up plugging 4 in up here. Okay? All right, we'll skip that part for now. Okay, so it says find the missing terms of the geometric sequences. So this is, we did one similar to this on the arithmetic. This is term number 1 is a half. Then we're missing term 2, term 3. So this is term 4, or a sub 4. Now, these guys here, again, I'm not sure what happened, but these guys should all be time sign. Not sure what's going on with my program here. So it should all be times. So think about this. If I took 1/2 and I multiplied it by r, I would get to a sub 2. If I did that again, I would get to a sub 3. If I did it one more time, it would equal a sub 4. So that's exactly what I did. I took my first term, times r once, times r twice, times r 3 times. If I multiply it by r 3 times, I get to term 4. It should equal term 4. Well, r times r times r is simply r cubed. So I'm going to simplify. 1/2 times r cubed equals 4 over 27. I want to get rid of the half over here. So I can divide it out, or I can multiply by the reciprocal instead. I would rather do that. Okay? And I'm going to make this guy a time sign here again. So by multiplying by the reciprocal, I come over here. These guys are going to cancel each other out. That means I'm left with r cubed. Over on this side, I can't cancel anything, so I have 8 over 27. How do you get rid of a cubed? You cube root both sides. You don't square root both sides, you cube root. Now watch what I did. I cube rooted the left, which means I cube root the right. And when you cube root a fraction, you can actually do this. You can cube root the top and the bottom separately. Makes it a little easier to think about sometimes. So anytime I see a root over a fraction, I just split it up like that. Oh, well, the cube root of 8, that's got to be 2. The cube root of 27, that's 3. There's my r value right there. Once I know my r value, it's just a matter of plugging it in and finding a sub 2 and a sub 3. So let's see if I wrote over the area where that's going to come into play here, okay? And of course I did. So here's my r value, 2/3. If I take that r value, okay, and I take my a sub 1, which was a half, 1/2 times 2/3. And we could actually do some canceling here. That's going to leave me 1/3. This is a sub 2. Now I take a sub 2 and I multiply that, 1/3 times 2/3. This time I can't simplify, so I get 2/9, and there is a sub 3. Okay? Once you guys try the next one, I think it's going to be a little bit easier because I don't think you're going to have the fractions like you did here, but you can give it a shot. All right. So again, I've got a little bit of a correction to do here. Again, I'm not sure what happened with my PowerPoint program here, but we'll just make those time signs. That's okay. So we're missing 1, 2, 3 terms. That means that a sub 1 is 2. So to get all the way over to a sub 5, all you really have to do is ask yourself, how many times do I have to multiply by r to get from 1 to 5? Well, that's 4 times, right? That's just r to the 4th. This time you can divide both sides by 2. So that's r to the 4th equals 81. This time you have to 4th root both sides. And 4th roots are like square roots. They require pluses and minuses. Okay, they require pluses and minuses. So I'm going to end up with 2 r values here. The 4th root of 81 is 3 and -3. Okay, so let's see if they both work. Okay, so the first thing I'm going to do is I'm going to look at 3, and I'm going to take my first term, I'm going to multiply it by 3. Okay, and that should give me the second term, and then we're going to look at -3 as well. So if I multiply 2 times 3, I get 6. If I multiply 2 times -3, I get -6. So now we need to multiply both of these guys. 6 times 3, negative 6 times negative 3. Let's see if it all works out. 18 times 3, 18 times negative 3. And one more time, 54 times 3, negative 54 times negative 3. Oops, that went a little bit quick, didn't it? So if I multiply both of these guys by 3, I do get 100, positive 162 for both of them. That means that both of these R values are good. Okay? So you gotta be careful with your fourth roots here. All right. I think we got one left here. What do we got here? It says if the fifth term of a geometric sequence is 6, so there you can see it, number 6, and the ninth term is 96. There we go, so there's a sub 9. What is the common ratio and the first term? Okay, so the first thing I got to do is find the ratio. Okay, so, and again, I can do that in a few different ways here, but let's change my G's again to time sign. I think you guys are getting used to this by now though, right? These are times. Just don't want anybody getting confused. All right, so this time I would take a sub 5 and I would need to multiply by 1R, 2R's, 3R's, 4R's. There we go. R times R times R times R. Perfect. Well, that's 6R to the fourth equals 96. So then I would have to divide by 6 on both sides. That gets me 16. I'm going to fourth root both sides again, and that's going to give me plus and minus 2. Now, I don't know if both of these are going to work, but we're going to find out. All right, what is the common ratio? Oh, and the first term, right? So the common ratio is plus minus 2. They want to know the first term. The first term can be found always going back to your explicit formula. Don't use the recursive for much of anything. The explicit formula is going to be the one you want 99% of the time. In order for me to find a sub 1, I need an a sub n, which means I know an n. So check this out. I took a sub 5. Why did I do that? Because a sub 5 has a value of 6. So if I plug in 5 here down on this subscript, I know my common difference is 2. And I know that this would be 5 minus 1, which is 4. But really, again, what I want here for a sub 5 is I want the value of 6. That's what a sub 5 is. It's 6. I still need the 5 minus 1 up here, so that's going to be 4. And 2 to the fourth is 16. Likewise, negative 2 to the fourth would also be 16. All right? So I think I'm okay using the positive and the negative here. If you divide out 16 on both sides, you get 6 over 16, which is 3/8. There's your first term right there. Okay? All right. Let's see. Are we done? Oh, we got one more here. Okay. So it says you throw a super ball on the cement as hard as you can and watch it bounce until it stops. You notice the first bounce reaches a height of 200 feet. So this first bounce here is 200 feet, but the second bounce reaches only half that height. So here's 200 feet, so that's 100, that's 50, that's 25, that's 12 and a half, blah, 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 all the way out 7 times. So could I do this recursively? Could I just keep figuring out what's half of this, what's half of this, what's half of this, what's half of this? Absolutely, okay? But we're gonna try it a little different. I'm going to label these guys. A sub 1 is 200, a sub 2 is 100, a sub 3 is 50, so on and so forth. But, you know, I could keep going. I only have to do it 3 more times, right? It's not so bad. I'm going to do it with the explicit formula, though. My R value is 100 over 200. Second term divided by first term, or third time divided by second. Here's my explicit formula right here. I want to know how high will the 7th bounce reach, so I need to find a sub 7. I know a sub 1, so here we go. A sub 7 is equal to a sub 1 times the R value of a half raised to the power of 7 minus 1. pop it in your calculator, and you get 3.1 feet high. Okie doke. And that is going to do it, ladies and gentlemen.